Okay, so in lecture 4, we're going to talk about now these key players of how we can have parasympathetic and sympathetic nervous system both upregulating and downregulating specific organs. All right, let's talk about the mechanism of how we get all these different cellular responses. So we're going to label this drawing autonomic nervous system mechanism. All right, now, 2 branches of the autonomic nervous system, and I'm going to start off with sympathetic, and then we'll talk about parasympathetic. Okay, now, remember, what is the wiring? We have to have 2 neurons in a, what's that word? In a series. Okay. I have 1 neuron. I'm trying to be careful with space because I'm bad at figuring out space. I always run out of space. Or leave myself too much space. And then I'm going to have my effector. And I'm not drawing the neurons right now different lengths because I don't want to deal with space. I'm going to run out of space. So you folks know what's going on, okay? This is parasympathetic. That's the first neuron. This is my second neuron. And it's my second neuron that's going to innervate my effector. All right, now let's play. You folks ready? These are the players. Let's get into the details and what they do. Because if you want to play the game, you have to know what the players do. So I'm going to first use blue. And in order to have an effector either be upregulated or downregulated, you folks already know that I have to have neurotransmitters. These are neurons. So this first neuron is going to secrete a neurotransmitter. This is acetylcholine. Okay, remember the abbreviation? Acetylcholine. And acetylcholine is going to bind to the postganglionic neuron. It's going to bind to the nicotinic receptor. And you folks already know what the nicotinic receptor does. The cellular response is going to be depolarized, always. All right? Now, let's do parasympathetic. Guess what it uses? Luckily for us, it also uses acetylcholine. And the receptor type is also the nicotinic receptor. REC is shorthand for receptor. Okay? What is the cellular response? Depolarize. If you want a signal to always be transmitted, whether it's neuron to neuron or neuron to effector, you always use acetylcholine with the nicotinic receptor, okay? Because the nicotinic receptor, the depolarization response is strong, okay? So if you're going to turn on either system, sympathetic or parasympathetic nervous system, you want to make sure that that signal is transmitted and integrated by that second neuron. So we use acetylcholine and the nicotinic receptor to ensure that depolarization happens in the second neuron that's going to upregulate or downregulate our effector, okay? Now, sympathetic neuron uses, or the second neuron in the sympathetic pathway utilizes the following neurotransmitters or hormones. I'm going to make it in red, okay? We're going to use the neurotransmitters norepinephrine and or epinephrine, always for the sympathetic nervous system. And we are going to bind to the adrenergic receptor. I hope I spelled that right. If not, I'm sorry. Love me or leave me. But please don't leave me because we got a lot of stuff to do right now. Okay, so adrenergic receptor. You folks good? Norepinephrine and epinephrine always binds to the adrenergic receptor. Now, how can that be? If I have the sympathetic nervous system being able to constrict and also dilate, it's because the adrenergic receptor has, guess what? Different receptor subtypes. Ha ha ha. Magical. So let's start talking about these receptor subtypes, because now we have a ligand. I know there's two, but still, if we just carried norepinephrine, it can bind these different receptor subtypes, and I'm going to have different functions. So here, we're going to learn three. This first one is the alpha-1 adrenergic receptor. Is an oh my God, I'm getting excited. Sorry. This is the adrenergic receptor subtype called alpha-1. And when norepinephrine binds to this alpha-1 receptor subtype, it is a G-coupled protein receptor, and it activates PLC, phospholipase C, which you folks know will go ahead and make IP3, which I hope you folks remember was going to bind to the calcium gate and let in calcium inside of this cell. And if this is a smooth muscle cell, guess what I can do? I'm going to color this in green. It's because this is the same color I used in the previous slide. I can contract or increase contraction. I'm just going to write contract for now. Ha 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 ha. Okay, you ready to do more? No? Okay. We're going to do some more. Okay, here we go. Now, alpha-1, guess what? There's also a beta-1. Hello, beta-1. Oh, beta-1. Okay, beta-1 utilizes adenylyl cyclase. You folks remember? Adenylyl cyclase can allow us to make cyclic AMP, which you folks know that this is a strong second messenger that can, in this case, also lead to opening up some calcium-gated channels. And I can let calcium into the cell. And guess what is going to happen? Calcium is going to allow me now to have contraction. And we're going to talk about the mechanism of how calcium induces contraction in the muscle lecture. So we're almost there. Okay? So for now, just memorize. And I did talk about this in Unit 1. Calcium is important in the body because it allows us to have contraction. Without it, we would die because we wouldn't be able to run smooth muscle or cardiac muscle. Okay. Now, there is a third receptor subtype, and this one is called beta-2. And there are more. There are way more, but this is good enough for now because we're going to talk about medications that utilize these receptor subtypes, and there's no need for us to memorize any more than these three. So again, beta-2 utilizes adenylyl cyclase. It does allow us to turn on cyclic AMP, but interestingly, this cyclic AMP is going to inhibit something called MLCK. And we're going to talk about MLCK in the smooth muscle lecturette, but I'm just going to write it down for right now. This is the myosin light chain kinase. Ooh, here's that word again, kinase. Remember, what do kinases do? They phosphorylate things. So if you phosphorylate myosin, then you can now have contraction of muscle. But if you inhibit this kinase, guess what's going to happen to your muscle? It ain't going to contract, that's for sure. That's when I can have dilation. And I just want to use red because that's the color that I used in the previous slide. Oh my God. Oh my God. Okay, we're done. That's exciting, right? That's it for sympathetic. This is the entire mechanism. This is how I get different cellular responses utilizing the same ligand. And I know there's two, but they're pretty much the same. Okay, I could just say epinephrine and it would be the same one ligand with different cellular responses because I have different receptor subtypes. Okay, let's do parasympathetic. And I have to calm down. I had a lot of dark chocolate, but this is very exciting stuff for me. All right, now, and I hope you're getting excited too. And because it's fun, not because you're stressed. All right, now, let's talk about what's going on from this second neuron to the effector, right? We need to have a ligand. It has to bind to its receptor. Ah, look. Parasympathetic is going to utilize acetylcholine again, okay? But it's going to have different receptor subtypes, okay? So it's going to bind to its cholinergic receptor, okay? So these are cholinergic receptors, but there are different types. And you folks already know these because I told you folks to memorize these. So let's now go back. I'm sorry, I'm getting punchy because I'm excited and because of the dark chocolate. There are two. This is M sub D. Okay, M sub D. You folks remember when acetylcholine binds to the M sub D receptor subtype, I can now open, and I'm just going to put cation channels. And remember, cat ions are positive ions because there's sodium, there's calcium, and I don't want to get into all that detail, but I just as long as you folks know is that I can now open up ligand-gated channels to allow me to have depolarization. And when I depolarize, what can I do? What can I do? Change your color to green, clickety click, 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 is because this is going to allow me now to have contraction. Okay? Now, change your pen back to black or write in the same color pen is fine. I'm just going to make this arrow black so I can stay with the same format here. What is the other cholinergic receptor subtype that does the opposite of depolarization? M sub H, okay? And you folks remember that I'm going to open potassium channels. And you folks know that the cell is going to be set up to where I got a lot of potassium inside the cell. So if I have the potassium channel open, potassium is going to rush out of that cell and I'm going to have hyperpolarization, okay? And what's going to happen to that cell? I'm not going to have contraction. I'm not. Just change it to red. This is when I can now dilate. Whoops, sorry about that. Dilate. This is important. Now, people, this is important. And this is important is because you folks need to understand how medications work, okay? And how the body works, right? So if you're going into nursing and if you give medications that now downregulate breathing, and if you give too much medications that downregulate breathing, you can kill somebody. If somebody comes in because they took a street drug that depressed their or upregulated their parasympathetic nervous system, but you gave them a medication that also downregulated their parasympathetic nervous system, you're going to kill somebody. If you're not going into nursing, this is also important because you folks are also taking medications. You need to know how they work. I know a lot of you folks are taking medications based on what you folks are reading on the web. And guess what? A lot of that shit on the web is wrong. All right? So know this. All right? All right. So we're going to wrap up this lecturette by giving you two practice problems. Okay? So this first one is you're running away from a tiger. So I want you to describe blood flow to the heart and heart activity. And I want you to do so by tracing the autonomic nervous system pathway, include ligand receptor type and response, and do the same for digestion, okay? Because what's happening right now when you're running away from the tiger. And then the second problem I want you folks to work on is what happens when you have an amphetamine overdose. So in here, what happens is you have rapid breathing. So if you don't remember from anatomy, I'll just refresh your memory. Breathing rate is different from bronchodilation. Bronchodilation just allows you to open up the airways. Breathing rate is controlled by different muscle types, one of which is the diaphragm. Yes? So if I can control the speed of the contraction rate of the diaphragm, that'll allow me to breathe faster or slower. That means my diaphragm is contracting and relaxing at a very rapid rate. So explain how this could occur, and then what medication would you prescribe this individual to counter this rapid breathing? Don't give me no brand names. I want mechanisms, all mechanisms of action. All right, that's it for this lecturette. I'll see you folks next for the lecturette that I don't remember what it is, but I'll figure it out now.